Okay, let's look at some further examples, but now let's bring in probability. Look at this example. Every client of a certain bank has a personal identity number referred to as a PIN code, which is made up of 5 digits chosen from the digits 0 to 9. There's 10 of them. If you go from 0 to 9, it'll be the 9 and the 0, which makes up 10. How many personal identity numbers or PIN numbers or codes can be made if the digits can be repeated or if they cannot be repeated? Okay, so let's have a look at that first. Number A there. Here we go. Well, here are our digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now look at that. There's a total of 10 digits there. 1, 2, 3, 4, 5, 6, 7, 8, 9 plus the 0 gives you 10. Okay. Now, if you look at the first question, is you've got 5 possible digits in a PIN code, and you may repeat any of those numbers. 0 through to 9 may appear anywhere in this code. So you could actually have a 4, 4, 4, 4, 4 if you like. Okay, not a good code. Probably they would say it's a little bit insecure, that one, not secure, so they'd want some different numbers really if you think about it. So let's have a look. In the first position you could have any of those 10. Okay, in the second position any of the 10, the third any of the 10, fourth and fifth any of the 10. So if you multiply that according to the counting principle, what you then have is 10 to the 5 total possible number of codes, which is 100,000 possible PIN codes with those 10 digits there. Okay, now if you're not allowed to repeat, okay, the digits, now what happens is a different thing happens. So if you can't repeat 1, 2, 3, 4, 5, you can choose 10. Any of the 10 can be used for the first position, but now you've used one. Say you've used 4, now you're down to 9, and then you're down to 8, 7, and eventually 6. So if you multiply this, how many possible PIN codes could you have? Would be this, and another way of looking at it would be 10 factorial. That's 10 total digits divided by 10 taken at 5 at a time. 5 possible digits in the codes. Okay, and if you work that out there, that's 30,240 possible codes. Okay, now the next one's a little bit tricky, so let's have a look at this one. It says, suppose that a PIN can be made up by selecting digits at random, and the digits you can repeat them. What is the probability that such a PIN will contain at least one 9? Okay, so it must contain at least one 9. Okay, now let's have a look at that number B. Well, let's look. There's all the code, the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now there's our 5 codes. Okay, our PIN code, which is made up of 5 letters. And what we'd be very interested in is what would be first the total number of codes. 10, 10, 10, 10, 10, which of course when we worked that out was 100,000. So that's the total number of possible PIN codes. Okay, that's the total possible number of PIN codes. Now we want a code that's going to contain at least one 9. So any code that we want to select must have 9 in. So we've got 100,000 total possible PIN codes available to us that would have 9 in or won't have 9 in. But now what we want to do is we want to look at the number of codes, that exclude 9, that do not have the number 9 in it. Well, let's have a look at this. Well, if you take that, if we exclude 9, okay, then we've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 codes, 9 possible numbers. So we've got 9 in the first, and because we can repeat, we can keep having 9 possible digits there, but we're excluding the number 9. But remember that then there will be 9 possible digits. There's 9 digits left if you exclude the number 9. Okay, alright, so how many would we then have here 9 times 9 times 9 times 9 times 9. If you multiply all that together, you're going to get 59,049. Okay, so that's the total number of codes that exclude, that do not have 9 in it. So if we look now at the number of codes, that contain at least one 9. Okay, that would be the total number of codes, subtract the number that do not contain 9, which would be this guy there. Okay, and that comes to 40,951. Okay, so these are the guys that contain at least, so there's 40,951 that contain at least one 9. There's 59,049 that do not contain 9 at all, and there's 100,000 that's of pins in total. Okay, so the probability of getting a pin code with at least one 9 would be the total, which is 40,951 out of the 100,000 there. That's bringing into probability. And then, of course, if we work that out, it's 0.41. Okay, a probability there. So remember, the 50,049 that would be the pin codes that do not contain 9. The 100,000 is really all the possible codes, and then if you subtract this, you're going to get 40,951, and these guys here, all these 40,951 would contain at least one 9, one or more 9s would be in, but 40,000, but if you look at that, the 59,049, they contain no number 9s. Okay, so then the probability would be 40,951 out of the total, which gives you 0.41 there.